Good afternoon. So we're going to be creating our first smart contract. We're going to deploy our first smart contract, and we're going to interact with our first smart contract with application calls. So the way that I do things on AlgoLearn, I do not use AlgoKit. I do everything from scratch. Um, it's a little bit less simple, but I also think that AlgoKit generates like a myriad of folders and files, and a majority of them I think are unnecessary. I'm going to show you templates for launching your smart contract and interacting with it that you could reuse over and over, and it'll always work with menial adjustments. Um, so first things first, so Visual Studio Code, go to open folder, just create a folder on your desktop called My First Contract or My First Project, whatever you want. Bring this up, click the paper icon with the plus, type in whatever you want. I'm going to put in my underscore first underscore contract dot py, has to end in py. Python should be installed, AlgoKit should be installed, and algorand-python, aka Puya, should be installed. For Python, just go to python.org, downloads, and install the latest version. If you already have Python installed, it's important you're up to date because Puya scales with Python, new Python versions. You could uninstall Python if you want and reinstall if you're not sure. Just make sure you close Visual Studio Code and reopen it to have the IDE interpret your new version of Python. If you go down to the bottom right, you'll see the current version you're working with, and you should see Python here. If not, you can click this, select Python, and you could also click this and select the version you'd like to use. When you install Python, there's two things you need to check off. There's run as administrator and also add Python to path. Those two need to be selected, otherwise you're always going to hit walls when you're trying to code on this IDE, I guess, but probably a lot of other environments. So once you have Python installed, it comes with pip natively, and pip is a way to, let me just click this, pip is a way to install libraries in Python. For example, you're going to need the pyalgorand-SDK, and then you're going to need AlgoKit. So pip install pyalgorand SDK, pip install AlgoKit, and pip install algorand-python. Once you have installed those three things, close Visual Studio Code, open it up again, and you should see, and lastly, you should have IntelliSense installed. So under extensions, if you search IntelliSense, you should see one for Python. Let's type Python IntelliSense. And you should get this one. Python v 2024.14.1 is the current one for me, but it will usually be the first result. And once that's all set, from AlgoPy, import arc4 contract. You should see this be green, and when you highlight over something like arc4 contract that you're importing, you should see all the details about this class and what it does, what it comes with, and that is a successful installation of Puya, which is algorand-python, and you are ready to go. So from AlgoPy, import arc4 contract, we're going to need string. We're just going to create the hello world example from GitHub, and we're also going to need the ABI method from the arc4 library here. So we're going to create a class, and I showed you an example of an archer class, I believe, recently. So this is very similar, a very similar concept. So you're just creating a class. The only difference is you pass in the arc4 contract here for the compiler. And for your first function, you're just going to say ABI method as a decorator. and create a function called hello and pass in self, and we're going to pass in a name, string. Type annotation, we have to return, indicate what we're going to return at the end of the function. And we're just going to return hello, comma and space, plus name. And at the bottom here at the terminal, you're going to type AlgoKit compile, py, and the name of your file. So I named mine myfirstcontract.py. And we hit enter, and hopefully it should give us some approval and clear programs in our JSON here. The JSON pretty much just lays out the methods that we have, the approval and clear source, the default global and local states, schemas, the name of the contract, all the methods included. And this is what you're going to be using when you create an application client. So we need to hang on to these three. Well, the approval and clear programs we use to launch the contract, and the JSON we use to interact with the contract using an application client, because it accepts the JSON as one of the parameters when you're constructing the application client. So now that we have our approval and clear, we can launch the contract. And just something I wanted to quickly say, so I don't know why my IDE has these red lines under algopy.arc4 saying it can't be resolved, but then it successfully imports the method. I've tried, let me see if this works. So if you highlight over it and hit quick fix, it'll just add type ignore, which just says like, hey, don't worry about this not being resolved because it still works. But I think that when let me save first. I think that when I try to compile, it says something about this type ignore. If not, then you can use that if it does bother you. Yeah, unused type ignore. Let me just double check something. I'm going to delete these and see if it still compiles the approval clear and JSON. Just one more moment. Yeah, it doesn't. So you kind of have to deal with the red lines. This is something maybe I would go into the AlgoLearn Discord and ask about. Or maybe Visual Studio Code probably has a Discord. But we can just ignore it for now. Contract still compiles successfully without it being resolved here. So now that we have our approval and clear, we can launch the contract. And I'm going to walk you through the steps to launch a contract from beginning to end. So we're going to create what happened here? Oh, need to save. Always save after you change something in your contract. Otherwise, when you compile, it's not going to recognize the changes. So you can save with Control S while you're inside the file, like click into it, Control S, or you can hit File and Save while you have the file open here. Okay, so we have these. So I'm going to create a new file called launch smartcontract.py. You can name it whatever you'd like. And we're going to need a node token and a node server. And if you're not running your own node, I did put out a tutorial on how to run your own node, a participation node that can double as a connection to the blockchain for sending transactions. You can just use the token and server that you get from your node using the cats.algod.token and cats.algod.net commands in your data directory of your node. If you're not running your own node, that's fine. We're going to go to nodely.io. So you could just Google Nodely and it'll be the first result, nodely.io. Click Quick Start. And then down here, you'll see Algorand endpoints. And we're going to go to the testnet row over to the Algod column. Because we don't need an indexer, we need a Algod client server. So we're going to copy this URL and go back to Visual Studio Code. And what we can do is, so I'm going to show you something different. Let's call this algot server is equal to and a string, empty string, and then paste in the server URL. And then algot token for Nodely, there's no token, it's public, so you don't need this. It can just be an empty string. You do need to declare it as nothing though, so empty string. So I would prefer that you get into the habit of using .envs, which is going to be this. Create a new file here. You can right click, hit new file as well, instead of the paper icon. Type in .env, period env. And in here, we're going to paste this information. So algot token and algot server, we're just going to put in here. And then in our launch smart contract, we're going to import OS. Just type import OS. And then the algot token is going to be os.getEnv. And pass in the name of the key in your env. So I have algot token and algot server. So we're going to just type it out this way as well. And now you don't have this information in your code. You can also do this for private keys, which we're actually going to do now, because we're going to need a private key. Empty string for now. Create a new file. Generate AlgoLearn accounts.py. And from algosdk.accounts, import generate account. And this function will return two strings, a private key and an account address, as a tuple. So what we can do here is say private key, comma, address is equal to generate account. And I don't know why this turns white all of a sudden, but that's fine. That's been happening lately. And then we're going to print private key and address. And we're going to run without debugging, Python debugger. And we're going to get our private key and our address here. So we're not going to need our address, except for right now. We're going to go to bank.testnet.algoran.network, paste in your new address. This is just going to be your testnet developer address. And then hit dispense, solve the CAPTCHA if you're not a robot, hit dispense, go back. And we only need the private key now, because there's a function, and we can just delete generate account, unless you want to save this. We're going to just define private key really quickly, and I'll show you why we don't store the address as well. And that is because from algosdk.account import address from private key. So the private key is going to be os.getEnv private key, as we named it here in our .env. And then the address is going to be address from private key, and this just wants a private key. We're just going to pass in the private key that we just pulled in from the env. Okay, so that's all the information we're going to need in the env file. Now we're going to set up our client, which is our connection to the blockchain. So algod_client. And we need to import the algod client class .v2client.algod. So from algosdk.v2client.algod import algod client. And now we're going to create an instance or an object of this algod client and pass in our algod token positionally with our algod server. You could also, if you'd like, the algod client, you could pass it in like this. So you could say algod token is equal to algod token, and algod address is equal to algod address. You could do it either way. So you have the parameter defined, and then your variable, and the same thing here, parameter defined, then your variable. But if you want to just use positional arguments, you can do just algod token, algod server. You won't need headers most of the time. I don't think I've ever used headers. This is optional. And you can confirm that your client's working if you'd like. Status is equal to algodclient.status and print status. And you'll see here that we're getting the information from the latest round. So we're currently on block number 44234875. This is the last round. I'm going to quickly close and reopen because I don't know why my variables are all discolored. So give me 1 second. I'm going to close and let me just open a new window. And bring this back in. Perfect. So status works. We don't need to save this. Make this a bit bigger. And the next thing we're going to need is the approval and clear teal source files. So we're going to say the name of our first teal file, the approval teal file, is going to be hello world contract.approval.teal. And our clear teal file name is equal to, and we're just looking over here, hello world contract.clear.teal. And this is where it's going to get a little bit complicated if you're new to Python. So we're going to use a with statement with an f string and point to the directory, which is this current folder. So for example, I'll show you an example afterwards. So f string, and then we're going to pass in these curly brackets and input our variable. So with open our approval teal file, and we're indicating the directory here as R, so we're reading, or not as R, but in reading state, as F, approval teal source is equal to f.read. So we're assigning opening the approval teal file in a reading format to the variable f, and then we're saying read f, and the results of reading f we're going to assign to approval teal source. We're going to copy this and paste it and do the same for the clear teal source. And I'm just going to highlight approval and press Control D and type clear. Now, when you highlight a specific sequence of characters and hit Control D, you can basically highlight all the instances of that variable, and then you can type whatever you'd like, and you see it all changes. So now that we have our clear and approval teal source read, we're going to compile them into so we need the approval and clear sources as bytes, and they're currently base 64 encoded, or they're going to be after we compile them. So we're going to say approval results is equal to algodclient.compile. So the client has a compile method, and then we're going to pass in our approval teal source. And I'll quickly show you what the approval result looks like. And this is why we had a chapter on dictionaries, because this is a dictionary. Almost everything that you get back from the blockchain will be in a dictionary, a JSON format. So the result here is what we need, which is this CIA, CAA, blah, blah, blah. I'm actually curious if this is already prepared for us. No, it's not. So it doesn't auto-compile with Puya, but that's fine. So we're going to compile it here, and we're going to need this result. So we're going to say, using key notation, because we know we can access the results key value by just inputting within square brackets the name of the key that we want to get the value of. And if I run this, you'll see that we get only this value here. So we're going to say the and this is the program. The approval program is equal to the result key in the approval result. And what we need is this actually in bytes. So we're going to import base64, or what we can even do is from base64, import b64 decode, because we want to decode this base64 encoded string representing the approval program. So b64 decode, and now you'll have a bunch of bytes. Perfect. Then we're going to do the same thing for the clear program. So I'm just going to copy and paste, highlight approval, Control D, Control D, Control D, and type in clear. Okay, now I have my approval and clear programs. When you create a transaction, or excuse me, when you submit an application creation transaction, you need to include the state schema for the contract. We go over state schemas later, so global and local states, but currently our contract does not use any global or local states. So we're still going to define it, but we're just going to set them to 0. And we need to, before I start typing down here, we need to import state schema as well as the application creation transaction class. So from AlgoSDK.transaction, import the application creation transaction, the state schema. We're going to also import onComplete, and I'll explain what that is shortly. We're going to import wait for confirmation, and let's also import payment transaction so we can send this contract, the MBR, to be an active account. So for any account on Algorand to be active, it needs a minimum balance of 0.1 Algorand. And we have 10 testnet Algorand, by the way, when we use bank.testnet on the website just now, or was it this, the Algorand dispenser? So we don't mind sending our contract 0.1 Algorand. So that should be good. And we're going to go back down here, and we're also going to need logic. And I'll explain this to you shortly. So go back up here from Algo SDK, dot logic import gets application address. So from Algo SDK.logic import get application address, and then make sure you imported all of these here. Then go back down. And the next thing we're going to do is create the schemas. So we're going to say global schema is a state schema. And I'm not going to use positional arguments. I'm going to actually pass in the parameters. So number of integers is going to be 0, and number of bytes, num byte slices, is also going to be 0. And we're going to do the same thing here, just copy and paste for our local schema. And what state schema is defined for the contract is how many integers worth of global state. So a global state can be either an integer or a byte sequence or byte array. So we don't need either for global state, and that's the same for local state. But let's say we had a global state, which might be difficult to comprehend now because we haven't seen actual examples of this. But let's say the contract had a counter, like how many people opted into it, and it keeps track of that. So if you opt in, it says 1. I opt in, it says 2, so on and so forth. And it just keeps adding up. That would be an integer. If I wanted to have a global state for some reason be a bunch of addresses, those are going to be in bytes, because think like characters and bytes. So an address is a bunch of characters. It's not a measurable number that you can perform arithmetic on. So we're going to use bytes in global state for things like addresses or strings. So if you had one counter in your contract that kept track of everyone who opted in and kept adding one, and then if you had one global state that was just keeping track of addresses, you would need a 1 here and a 1 here. And global state is global. It has nothing to do with a specific user. So I'm going to set this back to 0. Local state is specific to the user. So only the user adjusts their local states. So if I wanted to say number of times user used the contract, that would be an integer for that user specifically, and the user would have to be opted in to the contract. And by user, I mean person or whoever's interacting with the contract. They would need to be opted in for us to use local states. And same concept with the address here for byte slices. So if we needed one of each, we would put 1 and 1 here. And if the user opts out of the contract, this local state is deleted. That's why a lot of platforms kind of shy away from using local states. It's because local states they can be deleted by the user accidentally. So if they're staking with a website and they're using local state to keep track of how much, what their balance is, and then the user opts out, like they just lost all of their funds. So a lot of people shy away from local states. They started using application boxes, which we're going to get into using later in the AlgoLearn tutorial series. So we're going to create our transaction now. We're ready to go. So you can write out transaction is equal to, I just like using the shorthand TX, or you can use TXN, whatever you prefer. And we're going to say transaction is equal to application create transaction. And then we're going to pass in all of these parameters one by one. So the first thing we need is the sender. So our sender, we imported earlier, our address right here. We imported the private key and got the address from the private key. So right now this is going to be an address. So we're going to copy our address variable, paste it in here. Next thing is SP. SP stands for suggested params. We haven't got that yet, so we'll get it now. Params is equal to algo.client, and there's a method in the algo.client called suggested params. It's a function, so open and shut parentheses. And now we have a suggested params object that we could pass in to SP. Next up, we need an onComplete. OnComplete means when you're performing this application call, do you want the person who's sending this application call to opt in, or do you not want them to opt in? There are other options as well. So there's onComplete.optin. You can update the application. You can delete the application. But mostly we're going to be working with opt-in or no opt-in. So we don't need to opt into this contract right off the bat. So I'm going to say onComplete is equal to don't opt in to the contract. Next up is so we're up to approval program now. So approval program, we already created up here. So we're just going to say approval program, program is equal to approval program. Same thing with clear program, which is right after. Clear program is equal to clear program. Next up, we need to include the global and local schemas, which we already did up here. So global schema is equal to global schema. And local schema is equal to local schema. So we're passing in these down here to these parameters. Next up, app args. We don't need any app args. Accounts we don't need. Foreign applications we don't need. Foreign assets we don't need. We're actually done. That's all you would need. So I'm just going to bring the parentheses back up here. I like to enter this out so I have some space to create all the parameters and arguments. And we should have went over signing transactions already when we went over payment transactions. but we're going to say here, so I won't go into this in too much depth, but the signed transaction object is going to be transaction, and its method is sign, and pass in our private key from earlier. And now you're going to see we have a signed transaction object. If we print this here, or it might print the, signed transaction object. And we're going to send this object to the network. So what we're going to do is we're going to do a try except loop, because sometimes you run out of algo and it'll fail. Actually, we don't need a try except loop. If it fails, we'll know right away, and then it won't proceed. So we're just going to say transaction ID is going to be equal to AlgoClient and the method send transaction without an S at the end, because it's a single transaction, and pass in our signed transaction object. And send transaction returns a transaction ID, which we're going to have here in transaction ID variable tx_ID. And what we're going to do is print the transaction ID. We're going to use an F string again and put transaction ID in curly brackets. And then we're going to wait for confirmation. We passed this in earlier. We imported this earlier. And the wait for confirmation wants an AlgoClient and a transaction ID. So we're going to pass in our AlgoClient positionally, as well as our transaction ID. And once it's finished, so this is going to wait to confirm that the block is completed, and that we'll be able to get all the transaction information generated from the transaction being placed into the blockchain and confirmed in that round. So transaction info is going to be equal to AlgoClient.pending transaction info. This is kind of not straightforward. So it says pending transaction information. I feel like it should say just transaction info, because this transaction is no longer pending. But I've brought this up before. It's fine. Just leave it as is. Pending transaction info, pass in the transaction ID, and we're going to print the transaction info. And I'll show you why. So we're actually going to launch the contract probably twice, just so you could see an example. So the dictionary we get back, so it's waiting for the transaction to process. All done. It gives us the app ID that was created. So this is why right here I'm going to say print f-string app ID and pass in transaction info and use key notation to access the key called application index down here. Because we want to know our app ID, because we're going to put it in our end file to interact with the application later. And then I'm also going to want the application address. So app address is equal to, and we imported this from the logic library, get application address, which just accepts the application ID that we just got and returns the application address. So we're going to pass in we should probably actually do this, app ID is equal to transaction info, key notation application index, pass the app ID here, and then also in here. Okay. And then we can print f-string app address and app address. And we're going to have everything here ready to go. But I mentioned earlier that we do want to fund the application account with 0.1 Algorand, just so it can be an active account. So right after we get the transaction, the application deployed, and we get the app ID and the app address, we're going to create a payment transaction, and it's going to be equal to the payment transaction class here. So we can create an object from this. And this one is going to be simple. It's just going to be sender equals our address. SP is equal to the params we already have. They're good for, I think, about 100 blocks. So you can reuse it if you'd like. The receiver is going to be the app address. And the amount is going to be 100,000. Because 100,000 is the payment transaction wants the amount in microalgos. Microalgos is basically, so if I have one algo, I just times it by 1,000,000, and now I have 1,000,000 microalgos. So if I wanted to send 0.1 algo times 1,000,000, it would just be 100,000 algo. And if you're ever confused, there's a library called util, and they have something called microalgos to algos and algos to microalgos. So if you have algos and you want to get to microalgos, you just pass in, for example, 0.1 algorand. So let's say you want to send 0.1. Oh, what's going on here? Whoops. So if you're not sure, you can say, click in here, amount to send is equal to algos to microalgos, and you put in 0.1 algo. And then instead of typing out 100,000, you can pass this in here. Okay. But for the launch smart contract template, which you're going to reuse this over and over, you're never going to write this again. You're always going to have 0.1 algo here, just to activate the contract. This is my preference. You don't have to do it. But it's better than copying the app address, going to the Algorand dispenser and putting it in and funding 10 algo. It's a little wasteful for the testnet algo as well, because it's not infinite, it is finite. And now we're going to say signed payment transaction is equal to payment transaction dot sign. Same way we did the application creation transaction, pass in the private key. The transaction ID is going to be equal to algo.client.send transaction, singular, not plural, and pass in the signed payment transaction object and print transaction ID. What we can do is we can print an f string, say application funded with 0.1 algo for MBR, and pass in curly brackets with transaction ID. Put a little colon here just to have it neat. Okay, and then we don't need the transaction ID here. And we're good. I believe we're good. And we get the transaction ID. We can even say contract deployed for the future. We get the app ID, app address, application funded with 0.1 algo. Perfect. All we need is the app ID. So in here on our .env, we're going to say app_ID is equal to, and this number. This is going to pop out the other side when we read it, like how we read the token, server, and private key. It's going to pop out as a string. We need it as an integer most of the time, especially for the application client. So I'm going to show you, excuse me, how to convert that. But let's interact with our first contract, and that'll be the last thing we do in this video before we start getting into more complex contracts. So we're going to say, create a new file, call my contract.py, and this is going to be a bit hard to keep up with the first time, but once you do this once, you won't have to do it again. You can just copy and paste, put it into your memory if you'd like. So we're going to pass in, like we did previously, these things here. We're not going to need all of this. So we don't need this. We do need the client. We don't need to decode anything. We don't need the application address because the application client has a function to do that. Perfect. So let me start with importing the application client. Algo SDK, or actually it's going to be AlgoKit_utils import application client. And we're going to start constructing our application client. And let's create our Algo client ahead of time. Actually, no. Let's go down here. We're going to say application client is equal to and an instance of the application client class here. And we're going to see all the things that it wants. So the first thing it needs is an algod client. So we're going to create one here. Algod client is equal to algod client. And we're going to pass in our algod token and algod server positionally. Now we have our algod client is equal to algod client. Next up, we need the app spec, which wants an application specification object or path. I haven't delved into application specification objects. I just use path. You're free to look into that. I'm not going to do that right now, but I definitely will and see if it's easier than this. But we're going to say here, path is equal to path object underscore underscore file underscore underscore dot parent, and then we're going to pass in the directory to our hello world contract .arc32.json. And now we have a path. And I know that doesn't look easy. It looks a little bit different, but you can just reuse this code over and over. If you had the JSON in another folder, for example, called my contract JSONs, and you put it in here, my contract JSONs, when you go to call your contract, you would just put in that additional my contract JSONs. Okay, just so you understand how this kind of works. And I'll leave it like that for now. But you don't have to do that. You can keep it the way you just had it. I'll go back just in case I confuse anyone. App ID is equal to, and we got our app ID previously. Let me move this back here. In our .env, it's called app ID. So we're going to go back to call my contract, and we're going to say app ID is equal to os.getEnv, pass in the string for the app ID key. App ID is app ID. And then we're going to need a signer. So from algo SDK dot atomic transaction composer, we're actually going to need two things from here. The atomic transaction composer, and then we're going to need, and this is just, it's going to be an object where you kind of pile on all your transactions, and then you execute it with your client. And you'll see that later. And then we're going to need our signer, so count transaction signer. So for the next parameter signer, we're going to say, let's keep it organized here. Next argument signer is equal to, or we can even say my signer is equal to, not singer, account transaction signer, and pass in our private key. And now we have a signer. So signer is equal to my signer. And then next up, we're going to need our sender. And you can access this through your signer. So you can say my signer dots. Oh, you can't, sorry. It's just going to be your address, which we imported here. And the last thing we need is suggested params. And then we don't need template value mapping. So params is equal to algod client dot suggested params. And we're going to pass in params here. And now we have our application client ready to go. So we're going to say, because we want to interact with this at least once before we go, we want to call this method called hello, and it wants one argument, which is a name, which will be a string. So we don't need to pass in self. The contract knows what self is. It's initialized when it's created. All it wants is this. Okay, and it's going to be called hello. So we're going to go down here, and we're going to say call the hello method. You can call it whatever you want. This counts as a transaction. So we're going to say transaction, and it's an application call. We're going to create, actually, ignore me. This is not what we're doing. We're going to say application call dot compose call, and we're going to pass in our atomic transaction composer, which we'll call ATC. And this is what the transactions pile into before we execute. And we're going to say call ABI method. So it wants the atomic transaction composer, the ABI method we're calling. So call ABI method, and we're just going to write here hello, which is the name of the method here. It's going to be lowercase. And then it has a argument required called name, and it's just going to be a string. So hello and name will be what's returned. So name is equal to, we're going to say AlgoLearn community. Why not? And then that's it. And now to execute this, we're going to say results is equal to ATC, because when we compose a call, it adds the signed transaction with specified parameters to the atomic transaction composer. So we're going to use our atomic transaction composer with this method included into it. And we're going to say atc.execute, and it's going to want, the execute method wants a client and number of rounds to wait. So I'm going to say atc.execute algod client, and let's wait 2 rounds. I've tried waiting 1 round. It errors out for some reason. I'm not sure why. And we're going to print results.abi results. Where is... That's weird. atc.execute. It's weird. Let me just print the result. I think I'm missing... Oh, I didn't instantiate the atomic transaction composer. Make sure you open and shut parentheses after object creation. So we're going to print results.abi results. The first one, because there's only one transaction. So with list indexing, we use zero notation. So index notation starts with 0, always. We had a tutorial on this previously for list comprehension. So the first transaction will be 0. And we're going to get the transaction ID. And then I also want to print ABI results for the first transaction, and I want to get the return value. And you're going to see what's printed here. So if we run this, hopefully we don't get any errors. Oh, this is what I mentioned earlier. So although we pass in the app ID as an integer here, when we read it using os.getEnv here for app ID, it becomes a string. So you'll see if I highlight over this, it says it's a string. So we need to convert it to an integer because that's what the application client wants. I feel like it should take either or, but that's fine. And we're going to run this here, and it should work this time. And we should be good. It looks like it's sending the transaction. Perfect. So we got the result here, which is hello, comma, AlgoLearn community. And then if we take this transaction ID, and we go to AlgoKit, set it to testnet. So not AlgoKit, this is LoRa. So LoRa.algokit.io. And make sure you're on mainnet. So click here if you're not mainnet, testnet. So click here where it says mainnet. If it's on mainnet, set it to testnet. Paste the transaction ID here, and then you'll see the transaction that you executed. And you have here the arguments, everything that you're going to need to analyze your application call. And you have a bit of a visual here. We're going to make more complex transaction groups later, so this isn't as satisfying to see. But that's pretty much it. For your first contract, you have compiling it, and writing the contract. This is very simple. I know you want something more difficult, which we will get into in the next video. So we have compiling it with AlgoKit. You have launching it, and you can save this. You can reuse it as many times as you like. You'll only adjust values like this, the state schemas, and also the approval and clear file names. Other than that, everything else can stay the same. And then we have calling our contract by constructing an application client and composing calls. And all of this I'll put directly maybe below this video. And that's pretty much it. So next video, we're going to create a Archer contract. And what the contract will do is create a local state for a user. And you'll see in the next video. All right. Thanks, guys.